lowest common multiple. The next we're going to be doing is the LCM. LCM means lowest common multiple. We know what multiples of numbers are. You have to find the multiple common in the 2 or 3 values you are given. Then you have to find the lowest. Now let's take for example 2 and 5. What are the multiples of 2? You know your 2 times table. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12. Let's take that for now. Then we'll go multiples of 5. Multiples of 5 are 5 times 1, 5, 5 times 2, 10, 5 times 3, 15, 5 times 4, 20. I think that's enough. These are the multiples of 5. Let's take the first multiple of 5. Is there any 5 in this to know? The next multiple of 5 is 10. And we have 10 as the second multiple of 5. And we also have it as a multiple of 2. So this is the first common multiple in 5 and 2, which is also regarded as the lowest common multiple. Our LCM of 2 and 5 is 10. You can do it this way and get our answer, but this way seems more tedious. You have to first do the multiples, then you now find the common multiple. But we also know there's a second method of doing this, which is very common, and we'll be using that next. Method 2. The second method is to write out the 2 and the 5, the normal LCM style. The two numbers given to us, 2 and 5, and you start dividing them with prime numbers. We start with the first prime number, which is 2, that can go in at least one of them. 2 can go in 2, so you put 2 here. Unlike the H.C.F style, where you have to find the first prime number common in the 2 of them. But in this case, you have to take the first prime number that can go in at least one of them. And 2 can go into 2 in 2 is 1. Then 2 in 5 can't go without a remainder. And since it can't go without a remainder, you repeat your 5. The next prime number is 3. Once you've gotten to 1, you don't have anything to do with that 1 again. All you need to concentrate on is on the second or the other numbers that have not gotten to 1. 3 can't go in 5, so we'll take the next prime number, which is 5. You can see how important prime numbers are. So we take 5. Since we have gotten to 1, you just drop down the 1. Then 5 in 5, 5 divided by 5 is 1. Once you've gotten to 1 at the bottom, you've finished. So your LCM is now the multiplication of these two prime numbers, which is LCM equals 2 times 5, which is 10. 2 times 5 is 10. You can see that you can also use this technique or this method in solving for this and getting the same answer. And this technique seems less stressful, so we should note that. Example 2. We take the LCM of 4 and 16. We go. You have 4, we have 16. The first prime number that can go in at least one of them is 2. So 2 in 4, or 4 divided by 2 is 2. 2 in 16, or this 16 divided by 2 is 8. 2 can still go in at least one of them. You take 2 again. 2 in 2, 2 divided by 2 is 1. Then 2 in 8, or 8 divided by 2 is 4. You go for the next line, which is this one. You have 1 and 4. 2 can go in 4. Once you got into 1, you don't need to be concerned with that 1 again. You now concentrate on the next number, which is 4. Then 2 in 4, that's 2. Or 4 divided by 2, that's 2. You still repeat the 1. You've not gotten to 1, so we can't end it here. We go again and we say 2. You can first drop down this 1. Then 2 divided by 2 is 1. Once you've gotten to 1, 1, you've gotten to the end of it. You have to multiply all these prime numbers that were used to derive our 1, 1. So we have it as LCM of 4 and 16 is 2 times 2 times 2 times 2. You have it as 2 times 2, 4, 4 times 2, 8, 8 times 2, that's 16. LCM of 4 and 16 is 16. Example 3. Now let's take the next values, 8 and 12. LCM of 8 and 12. You have 8 and you have 12. So the first prime number that can go in at least one of them is 2. 2 can go, you take your first prime number. 2 in 8, or 8 divided by 2 is 4. 12 divided by 2 is 6. 2 can still go in at least one of them, so you repeat your 2. 4 divided by 2, or 2 in 4 is 2. Then 2 in 6, or 6 divided by 2 is 3. 2 can still go in at least one of them. 2 can still go in 2, so you repeat 2. Provided the smallest prime number can go in any of them, you keep repeating it. So 2 divided by 2 is 1. Then 2 in 3, get your remainder. So all you do is just repeat the 3. Now 2 can't go in 3. The next prime number is 3, and 3 can go in 3. So you write 3. 3 and 1, just repeat the 1. All you're concentrating on is this 3. So 3 divided by 3 is 1. Once you've gotten 1, 1, you've gotten to the end of it. So you have your LCM as the multiplication of all these prime numbers. So you have LCM is 2 times 2 times 2 times 3. 2 times 2, 4. 4 times 2, 8. 8 times 3 is 24. So the LCM of 8 and 12 is 24. So we should note that. Example 4. For the last question, we have 9, 12, and 15. The LCM of 9, 12, and 15. So write it 9, 12, and 15. We go with the first prime number, that is 2, that can go in at least one of them. 2 can go in 9, but 2 can't go in 12, so we just use it. Since 2 can't go with 9 without a remainder, or 9 can't divide 2 without a remainder, you repeat your 9. Then 2 in 12 is 6. 2 can't go in 15, or 15 divided by 2, you get a remainder, so you repeat your 15. So can 2 still go in any of them before we switch to the next prime number? 2 can go in 6, so take 2. 2 can't go in 9 without a remainder, so repeat 9. 2 in 6, or 6 divided by 2 is 3. 15 can't divide 2 without a remainder, so repeat 15. Look at the next line. 2 can't go in any of them. So the next prime number is 3. You take 3. 3 can go in 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Then 3 in 15, or 15 divided by 3 is 5. Now we have this. Once we've gotten to 1 here, we need not to concern ourselves with this. Now we have 2 numbers left. We have 3 and 5. Can we still use 3? Yes, 3 can still go in one of the 2 numbers left. So we have 3. 3 in 3, 1. You repeat it 1. Then 3 in 5, since it can't go without a remainder, or 5 divided by 3 can't go without a remainder, you repeat 5. We now jump to the next prime number, which is 5. Because 3 can't go in 5 without a remainder. And the next prime number is 5, so we use 5. We need not to concern ourselves with these ones, so we repeat them. Then you have 5 divided by 5. 5 divided by 5 is 1. Once we've gotten everything to 1, 1, 1, then our LCM can be gotten by multiplying all these prime numbers that were used in dividing all these values. So we have it as LCM is 2 times 2 times 3 times 3 times 5. 2 times 2 is 4. 4 times this 3 is 12. 12 times 3 is 36. And 36 times 5 is 180. Which is our LCM of 9, 12, and 15. This is the first number that these 3 numbers can divide without a remainder. Any other number less than this cannot be divided by all these numbers without getting one of them to give you a remainder. So that's the meaning of LCM. The first common multiple of these 3 numbers is 180.